Hey families, hopefully you got to watch the last video and were able to make sense of the double half strategy and the smart factor strategy, and maybe even jump into the partial product strategy for multiplication. And I said strategy a whole bunch of times there. And I'll say it again because we're going to do another strategy. I'm going to use the partial products method and tie it to another commonly used strategy. Most people will call it the standard algorithm because it's the most commonly used in upper level mathematics. Students typically leave this and the other more concrete representations behind, but not to think that these are inferior. So anyhow, I'm going to do my best to make sense of the standard algorithm, as it's commonly called, and its relationship to the partial product method. A couple examples of that, and possibly some of the other ways that children have been multiplying multi-digit numbers. So without further ado, we'll jump in. The number 26 times 4 is written like this in the standard, most commonly used algorithm. Over here, we've broken it up into its parts, where the 4 ones are being multiplied by the 6 ones, and the 4 ones are being multiplied by the 2 tens. As I'm talking over here, I'll try and make a relationship to this as best as I can. The 4 ones being multiplied by the 6 ones gives me a product of 24, where I drop the ones here and carry the tens, which is oftentimes the place where students get caught the most, and they enjoy writing it here because it's less confusing, less opportunity for error. With some training and some practice, this doesn't become much of a holdup though. Then the 4 ones are being multiplied by the 2 tens. Over here, we see that it's 80. We'll say 4 times 2 is 8, plus the 2 tens we carried from the previous product, giving us a final product here of 104. The partial product method over here just requires the children to add the two products. 4 and 0 is 4, and 2 and 8 make 10. So 104 from this method, 104 from this method, so they both. The next method that I'm going to show is the lattice method of multiplication, also known as the sunny window, also known as the confusing method with a whole bunch of lines that make me dizzy. However, some of the kids, they like this, and so I'll just show it for the sake of parents that are looking at their children and saying, "What are you doing? What is that?" And this is going to provide at least a topic of conversation, and I'll apologize in advance because it is kind of difficult to grasp your head around at first. But anyways, let's jump into it. I'll start simple, and then we'll get going with it. So anyhow, 20, I don't even know why I always go 20, 23. There we go, Michael Jordan. And we'll times it by one of my favorite numbers, 7. And the biggest thing, and I'm still writing like this. I apologize. I'm going to try and get better about that. The biggest thing is the chart, if you will, to this. And yes, I know you're saying, well, I thought, Mr. V, you said we're trying to get away from charts. Well, this one is for children who still like a pictorial or a graphical representation or a flow chart for their numbers. So anyhow, this is a 2-digit number times a 1-digit. So make notice there's a 2 box and a 1 box. So 2 here, 1 here. Then they come to this middle intersection, make a diagonal, and this right intersection or right corner and make a diagonal. And mine sloped, but it's no big deal. Then they copy the number, and I'll erase it after I copy it in this fashion here. And what this does is it breaks up each individual digit. Still pertaining to place value, this is the ones place diagonal, this is the tens place diagonal, and this is the hundreds place diagonal. And it'll make more sense as you see more examples of it. But 7 times 3, basic known fact, is going to be 21, 2 tens and 1 of the ones. Then 7 times the 2 tens over here, 7 times 2 is 14. If we had 7 times 2 tens, it would be 140, and it fits in the diagonals nice and neat. Then, after they've multiplied, I often encourage children to just cross through them so they don't confuse them. And then they add the diagonals. So what that means is these diagonal rows that are slanted this way, you're going to add the digits that are in them. This 1 is by himself, this 2 is being added to the 4, and this 1 is by himself. Then, starting to the furthest to the left, the highest place value, you just rewrite them. So 1, 6, 1 is the answer to 23 times 7. I'll do another one of those. Hey guys, for the sake of time, I went ahead and made the chart, and you're probably saying, "Oh my goodness, this is a lot going on," or you may say, "Hey, it's pretty neat." But this one is a double digit by double digit, and children. The children that like this method, they really feel empowered using it to multiply larger numbers. And in this case, we're doing 26 times 14. Okay? And to jump into it, we just start with, it doesn't matter, we start with one of the digits over here on the right. I'll start with the 1 because it's super easy, and it shows one of the holdups of this, if any. 1 times 6, make sure that it's written in this first little triangle here rather than the top one, because it is very important not to write it in this one. This one is actually going to take a 0 for a placeholder. So if you have a single digit answer, it's going to be written as 0, then the single digit. In this case, 1 times 6 is 0, 6. 1 times 2 is 0, 2. The only reason we do that is just to make sure that the triangle is full with a digit that includes no value. Thus, when they add the diagonals, there aren't any mistakes or any holdups, and the answer is logical. 4 times 6 we know to be 24, and 4 times 2 we know to be 0, 8. 4 times 2 is 8. I'm saying it is 0, 8 so I can write it in the correct manner. Encouraging children to cross out the digits that they've multiplied. They'll now turn to adding up the diagonals. 4 here. And then this is where smart tens come in. So quick 10, quick 5, the children have been working with this and learning this language for quite some time. We reinforce it in 5th grade to look for a quick 10 fact. We know 8 and 2 is our quick 10. 8, 9, 10 right there. Plus 6 is going to make 16. So that simplifies that. This here is the last holdup, but just like regular addition, if you make more than 10, you carry the 10s over. In this case, you carry it to that column there. You're now adding this diagonal. 1 and 0 is 1, and 2 is 3, and 0 remains 3. The 0 here does not need to be written. Then you just write the digits out as 3, 6, 4, and that in fact is the answer to 26 times 14. Hopefully that didn't make you quit the video. 26 times 14, I left on the board to reintroduce or to allude to the double half strategy. Sometimes children will say, well, I don't know how to do double digit, and 2 digits times 2 digits, and it prevents them from trying. And the good thing about the double half strategy is that we can double 26 and half 14, and watch what happens. It's cool when kids take the liberty of working with the numbers and of manipulating them in a way that makes them feel more confident and at least able to solve it. So to double 26, some children will write it like this and add it together. 6 and 6 is 12, 2 and 2 is 4, and 1 is 5. So they doubled that to get 52, halving 14 to get 7. So now they've taken something that they couldn't do, 2 digits times 2 digits, and made it 2 digits times 1. And then the children will either use their standard method or they'll use their partial product. Because partial product seems to be a holdup for some families, I'll just go ahead and solve it that way. And I apologize if I'm coughing or seem to be like pausing or working with a cough drop. I'm kind of getting some sinus stuff going on, so I'll do my best to keep that to a minimum. Just wanted to throw that out there. 52 times 7 will break up as 2 partial products, and we know it to be 50 and 2, both being multiplied by 7. And 5 times 7 is nice and easy of 35, making sure to add that 0. 2 times 7 gives me 14, and if I don't run out of room, I'll be good. I'll add them up. 0 and 4 is 4, 5 and 1 is 6, and 3 is 364. So, 26 and 14, double half down to get 52 and 7, multiply them out by partial product, we still get an answer that is 364. This next segment in the video is for the families and the parent groups or guardians trying to take care of double-digit multiplication by the standard algorithm, and they really want to reinforce that at home. I'm totally fine with whatever you guys want to reinforce at home, so I'll just give you an example of the double-digit standard algorithm, and I will not connect it to other methods just to simplify it as a solid example of 2 by 2 digit algorithms. And we'll do 45 times, I don't know, 13. Lucky 13, right? Sure. It's not as bad kind of level. And in this case, remember, friends, always start at the ones. Sometimes I'll have kids, if they're working on dry erase boards, I'll have them highlight it, the digit they're working with, and just to kind of give a visual cue, we call it zooming in. The kids and I talk about that. But in this case, it's 3 times 5 is 15, remembering to drop the ones and carry the 10. And then 3 times 4 is 12, remembering to add the 10 that you carried. So 3 times 4 being 12 plus 1 is 13. Now, this step often can be kind of a hurdle for kids. So what I encourage them to do is to cross out the digit, cross out the carry digit, and when you do that, add a 0. It simplifies it, and it encourages good habits and prevents mistakes from incorrectly identifying the 1 being tied to multiplying this one down here. So because I have this fancy green marker here, I'll just go ahead and zoom in again. Now I know I'm multiplying by the 10 here, which does make sense of why I add the 0. It's now in the 10's place rather than the 1's place. So the 1 times the 5, or 10 times 5 being 50 here. Wait a minute. That's 5. Here we go. Let's fix him. There we go. He's a better looking 5 now. This 1 times 5 is 5, and 1 times 4 is 4. And now it makes sense as to why I crossed this out, because some children would have incorrectly added that and got the wrong product down here. Starting in the 1's place value, 5 and 0 is 5, and 3 and 5 is 8, and 1 and 4 is 5. So, checking this, 45 times 13 is 585. We would know that to be reasonable, because if it were 45, well, imagine this. If it were 50 here, if we rounded this to 50, and we rounded this down to 10, 50 times 10 would be 500, making our answer of 585 completely reasonable. And there's an example of double digit. Thank you guys for watching the video and sticking with me. If you have any questions, always email me. You can comment down below here of the YouTube video, and I will do my best to get back in a timely manner. As I conclude this, though, I want to just make sense of the power of 10 and how it applies to this understanding of multiplication. And in the progression of our 5th grade standards, we do get into using the multiplying and dividing by powers of 10, and so it's going to come back around. I just want to touch on it because I noticed that some of the children were confused on it, and I want to make sure that we have opportunities to see it again and again. So without further ado, we'll jump into 10 to the 2nd power and 10 to the 3rd power. Some of the kids made the quick and obvious understanding that this little floating 2 here does not mean 10 times 2, so this would not be 20. And this does not mean 10 times 3, so this would not be 30. That it actually means that this 10 is being multiplied twice, and this 10 is being multiplied 3 times. And if it were 10 to the 4th, it would be 4 times, which looks like 10 times 10 up here, and 10 times 10 times 10 down here. And now, I'll do it in a different color. We can see that this over here is equal to 100, or a 1 with 2 zeros. And this is equal to 1,000, or a 1 with 3 zeros. That got really confusing because I didn't put an equal sign there. Apologize. How about that? Huh? That's not bad. That's a weird one. How about that? Yeah? Okay, that's not bad. This is just a little bonus in here. A lot of the children did quite well with it, but I just wanted to throw it in there just as a refresher and make sure that it was on the video somewhere. Thank you for watching. If you need to pause, rewind, do whatever. If these aren't helpful, I will do my best to make them better. When I get my tripod up, I think there'll be better recordings. And as always, guys, if you need to see something else, if you have any specific videos that you would like to see, ask me, and I can record them and render them and put them up to YouTube, typically within the day or the next day. So thank you so much for supporting us teachers here. We really love being a part of your children's daily routine, and I know me personally, I really love math a lot.